Good morning, children. Let's continue with exercise 8.4, question number 5, subdivision 8. Another important question which will be asked as such for the exam. The same question will be asked. Sin A plus cosec A the whole square. Sin A plus cosec A the whole square plus cos A plus sec A the whole square, cos A plus sec A the whole square is equal to 7 plus tan square A plus cot square A. Tan square A plus cot square A. It also can be noted as a very important as such. The question will be asked the same way. Very important. 4 marks or 3 marks. 4 or 3 marks. Study as such. And now this question, not like the other one of conversion of cosec A is 1 by sin A, sec A is 1 by cos A. Not in the first step. The first step is direct expansion. So LH is equal to sin A plus 2 sin A plus cosec A the whole square plus cos A plus sec A the whole square, which can be expanded as A plus B whole square sin square A plus 2 sin A cosec A plus cosec square A plus cos square A plus 2 cos A sec A plus sec square A. First step is direct expansion of A plus B whole square. Now let us group sin square A plus cos square A will be the first set. Then the next conversion will be 2 sin A cosec A. That terms will be changed as 2 sin A into cosec is 1 by sin A plus. The next important concept is this cosec square A will be changed as the identity of 1 plus cot square A. Similarly, 2 cos A sec A will be changed as 2 cos A into 1 by cos A plus sec square A will be taken as 1 plus tan square A. Will be taken as 1 plus tan square A. That means all the three identities have been applied here. Sin square A plus cos square A is taken as 1. Now, cosec A is changed as 1 by sin A. Similar term here, cos A and sec A is converted. Same way, cosec square A is 1 plus cot square A. Sec square A is 1 plus tan square A. This will give you the direct answer. Sin square A plus cos square A is 1 plus sin A and 1 by sin A 2 plus 1 plus cot square A plus cos A and cos A 2 plus 1 plus tan square A, which gives the answer as 1 plus 2 3 plus 1 4 plus 2 6 plus 1 7 plus cot square A plus tan square A. The question can be studied as such. The eighth one, cosec A minus sin A into sec A minus cos A is equal to 1 by tan A plus cot A. Yeah. Let's take the left hand side first. LH is equal to cosec A minus sin A into sec A minus cos A. This cosec A can be written as 1 by sin A minus sin A, 1 by cos A minus cos A. The LCM is by 1, that is 1 minus sine square A by sine A into 1 minus cos square A by cos A, which is the same as 1 minus sine square A is cos square A by sine A into 1 minus cos square A is sine square A by cos A. Cos A gets cancelled and sine A gets cancelled, and finally the LHS answer is cos A sine A. So similarly, we have to get RHS also the same answer as cos A sine A. Let's prove it as 1 by tan A can be written as sine A by cos A plus cot A can be written as cos A by sine A, which is equal to 1 by, again, LCM of sine A cos A. First term will be multiplied with sine A. Second term will be multiplied with cos A. It will be sine square A plus cos square A, which is equal to 1 by sine A cos A, which is equal to sine A cos A. Therefore, LHS and RHS are equal. This is another example of proving the identity by proving separately LHS and RHS. Subdivision 10. You have to prove both these quantities are equal to tan square A. 1 plus tan square A by 1 plus cot square A. This is the same question you have already done in the beginning of the exercise. 1 plus tan square A is sec square A divided by 1 plus cot square is cosec square A, which can be written as 1 by cos square A divided by 1 by sine square A, 1 by cos square A into sine square A divided by 1, or sine square A by cos square A, which is equal to tan square A. How to prove the second part? 1 minus tan A by 1 minus cot A, the whole square, can be written as 1 minus sin A by cos A divided by 1 minus cos A by sin A, the whole square, which is the same as cos A minus sin A by cos A divided by sin A minus cos A by sin A, the whole square. The next step is multiply by the reciprocal, which is the same as cos A minus sin A by cos A into sin A divided by sin A minus cos A. From this step, if you see here, cos A minus sin A and sin A minus cos A can be made as equal by taking a negative 1 outside, which can be proved as cos A minus sin A divided by cos A into sin A divided by, just rearranging as, even if you arrange it like that, minus 1, take it out. So when minus sign goes with cos A, you will write cos A in the beginning. Then it is positive sin A means negative into negative is giving you positive. It makes sure that you can cancel those terms, and there is a whole square here. Now sin A by minus cos A is the same as minus sin A by cos A, the whole square. Minus sin A by cos A is minus tan A, the whole square. Minus 1, the whole square is positive 1 similarly. Minus tan A, the whole square is the same as tan square A. By this, the exercise questions are complete, and now we will be proceeding with the worked out examples to give you more practice in this lesson. Even then, lot of workout is needed in this particular lesson. First, concentrate on the textbook questions, complete it fully. That means each exercise, work it out and make it thorough. Then proceed with the extra questions which are available in the practice books. Let's move on to the worked out examples. First question, page 178, example 1. Given tan A is equal to 4 by 3, find all the other trigonometric ratios. Given tan A is equal to 4 by 3. Tan A is equal to 4 by 3. Make sure that you are marking A as an acute angle. Tan is opposite by adjacent. You will mark it as 4K and 3K. If you have to get the hypotenuse, it is the addition. So 4K the whole square plus 3K the whole square, square root of 16K square plus 9K square. Square root 25K square is the same as 5K. Find all the other trigonometric ratios. So the first one is sin A is equal to 4K by 5K, which is the same as 4 by 5. Cos is equal to adjacent by hypotenuse, which is 3 by 5. And tan is already given. Now the reciprocals. Reciprocal of sine is cosec A is 5 by 4. Reciprocal of cos is sec is equal to 5 by 3. And reciprocal of tan is cot, which is equal to 3 by 4. I selected all the worked out examples together so can revise the topics once again. Question number 2. If angle P and angle Q are the acute angles such that sin B is equal to sin Q, prove that angle B is equal to angle Q. This is the same like exercise questions by proving similarity. If angle B and angle Q are acute angles. Let me take the same figure from the textbook. It shows triangle ACB, C is right angle, and PR, PQR, Q is taken here and R is right angle. So it's given that sin B is equal to sin Q. Sin B is equal to sin Q. Sine ratio is opposite by hypotenuse. That means AC by AB is equal to sin Q is PR by PQ. PR by PQ. The first step was to cross multiply AC into PQ is equal to AB into PR and arrange as the proportions like ratio of the sides from both the triangles. That is AC by PR is the same as, along with AC, PQ, it will be retained here, AB by PQ, let it be equal to K. That is a constant, which shows that AC can be written as KPR and AB can be written as KPQ. Now our intention is to prove the triangles are similar. For that, take the third side. Which is the third side here? AC by AC and AB is given. That means we need to get what is BC by QR. BC by QR is equal to square root of AB square minus AC square divided by QR is the same as PQ square minus PR square, which is the same as square root of, let AB can be written as KPQ the whole square, KPQ the whole square minus KPR the whole square by PQ square minus PR square, square root of K square into PQ square minus PR square by PQ square minus PR square, square root of K square is the same as K, which shows that AC by PR is equal to AB by PQ is equal to BC by QR is equal to K. Therefore, triangle ACB similar to triangle PRQ by S is a similarity, or angle B is equal to angle Q, which then also you can give as proportional or equal angles of similar triangles. This is worked out example 2. Page 179, example 3. Consider triangle ACB right angled at C. Consider ACB right angled at C, in which AB is equal to 29 units. Hypotenuse is given as 29 units. BC is equal to 21 units. And angle ABC is equal to theta. Determine the values of cos square theta plus sin square theta. And the second value of cos square theta minus sin square theta. Since you know the identity now, what is the possible answer of cos square theta plus sin square theta? Whatever be the values, it will be 1. The first answer will be 1. We can define it. Now, AC is equal to square root of AB square minus BC square. Since they have given the word 29 units, let's go with that only. 29 square minus 21 square, square root of 29 is square is 841 minus 441. Square root of 400, which is equal to 20 units. It is a Pythagorean triplet, 20, 21 and 29. Cos square theta plus sin square theta. Cos theta is adjacent by hypotenuse and sin theta is opposite by hypotenuse. Therefore, cos square theta plus sin square theta is equal to 21 by 29 the whole square plus 20 by 29 the whole square, which is the same as 441 by 841 plus 400 by 841. 841 divided by 841, the answer is 1. It is clearly confirming the identity cos square theta plus sin square theta is equal to 1. What is the answer for cos square theta minus sin square theta is 21 by 29 the whole square minus 20 by 29 the whole square. 441 by 841 minus 400 by 841, or the answer is 41 divided by 841. Worked out example 4. Right angle ABC, right angled at B, page number 180. Example 4. In triangle ABC right angled at B, right angled at B, tan A is equal to 1. Tan A is equal to 1. Tan means opposite by adjacent. 1 means you can take it as 1 by 1. Verify that 2 sin A cos A is also 1. Prove that 2 sin A cos A is equal to 1. As AC has to be found out as square root of 1k the whole square plus 1k the whole square. That is 1k square plus 1k square is 2k square, or it is square root of 2k square or root 2k. Root 2k. Now, what is to prove is 2 sin A cos A. So, sin A is equal to opposite by hypotenuse. Cos A is equal to adjacent by hypotenuse. Now substitute in the LHS. 2 sin A cos A is equal to 2 into 1 by root 2 into 1 by root 2. What is root 2 into root 2 is 2. So 2 into 1 by 2, or the final answer is 1, or which is equal to RHS. Page 180, example 5. In triangle OPQ, right angled at P, OP is equal to 7 centimeter and OQ minus PQ is equal to 1 centimeter. OQ minus PQ is equal to 1 centimeter. That means OQ is equal to 1 plus PQ. You can take it as for simplification. OQ is equal to PQ plus 1 and PQ you take it as PQ. Apply Pythagoras theorem. OQ square is equal to OP square plus PQ square. OQ is the same as PQ plus 1 the whole square is equal to 7 square plus PQ square. PQ square plus 2PQ plus 1 is equal to 7 square plus PQ square, or 2PQ is equal to 49 minus 1. PQ is equal to 24. And this is 25. 24 and 25 centimeter. You are supposed to find the values of sine Q and cos Q. You have to just write the values of what is sine Q and cos Q. Sine Q is opposite by hypotenuse and cos Q is equal to adjacent by hypotenuse. That is worked out example 5. Page 185, 6 and 7, I think we can just discuss orally because the questions are very simple. Question number 6. In triangle ABC right angled at B, AB is equal to 5 centimeter, angle ACB is equal to 30 degree. Determine the length of the sides BC and AC. It is direct application of sine 30 and cos 30 values. Similarly, example 7. In triangle PQR right angled at Q, PQ is equal to 3 and PR is equal to 6. Find the ratio, find the angle QPR. Angle QPR, they should know. It is adjacent by hypotenuse. Use the ratio and get the value of the angle. That is also a simple one. Let's move with example 8. It's a very important worked out example. Example 8. Sine of A minus B is equal to half. Cos of A plus B is also equal to half. Find the values of A and B. That means A lies between 0 and 90. Sine A minus B is equal to half. As I used to tell you, sine of which angle is giving you half? That is 30 degree. You can compare the angles and get the first equation as A minus B is equal to 30 degree. Similarly, cos of A plus B is equal to half. Cos of which angle, known angle to you is half, is 60 degree. Compare the angles, or A plus B is equal to 60 degree, equation number 2. If you just add the equations, positive B and negative B gets cancelled. 2A is equal to 90 degree, or angle A is equal to 45 degree. Substitute in any one of the equation. 45 minus B is equal to 30, minus B is equal to minus 15, or angle B is equal to 15 degree. That is worked out example 8. The next is with the complementary ratios of example page 189. It's a very simple concept. Example 9, example 10 and 11. Evaluate tan 65 by cot. Example 9. Tan 65 by cot 25. Change only one of them. Which are the complementary ratios? Sine value and cos value. Cos and sine value. Sec and cosec value. Tan value and cot value. Changing tan 65 as cot. 90 minus 65 by cot 25. Cot 90 minus 65 is cot 25 by cot 25, which is equal to 1. Example 10. Sin 3a is equal to, if sin 3a is equal to cos a minus 26. Cos a minus 26, find the value of a. It's a very important question. Changing sign as cos 90 minus 3a is equal to cos a minus 26 will be retained as such. Comparing the values of the angles because both sides ratios are cos. 90 minus 3a is equal to a minus 26. 90 plus 26 is equal to a plus 3a. 116 is equal to 4a, or angle A is equal to 116 by 4. 4 2s are 8, that is 629 degree. It's a very important worked out example. And the last one, 11. Express cot 85 plus cos 75. Number 11. Express cot 85 plus cos 75 in terms of angles between 0 and 45. Change both using complementary. Tan 90 minus 85 plus sin 90 minus 75. That is tan 5 degree plus sin 15 degree. Both 5 degree and 15 degree are angles between 0 and 45 degree. Page 191, example 12. Express the ratios of cos A, tan A, sec A, all into the terms of sin A. You have to bring all the expressions into the terms of sin A. Identity is cos square A plus sin square A is equal to 1. Therefore, cos square A can be written as 1 minus sin square A, or cos A can be written as square root of 1 minus sin square A. Now, tan ratio has to be made into the sin ratio. Now, tan is sin A by cos A, which can be written as sin A by cos A is square root of 1 minus sin square A. Next is sec A. Sec is 1 by cos A, which is the same as 1 by square root of 1 minus sin square A. It's an easy question because all the answers are interrelated. Next one can be written as prove that, it's identity. Prove that sec A, example 13, prove that sec A into 1 minus sin A into sec A plus tan A is equal to 1. Convert all or express each ratios in terms of sin theta and cos theta. Sec A can be written as 1 by cos A. 1 minus sin A will be retained as such. Sec A plus tan A can be written as 1 by cos A plus sin A by cos A. LHS equal to, which is the same as 1 by cos A into 1 minus sin A into, LCM is same, 1 plus sin A by cos A, because it is multiplication, or 1 by cos A into 1 minus sin square A by cos A plus B into A minus B. 1 minus sin square A is cos square A by cos A into cos A is again cos square A, which is equal to 1, which is equal to RHS. Example 14, prove that cot A minus cos A by cot A plus cos A is equal to cosec A minus 1 by cosec A plus 1. Now by this time you will be understanding that either one side has to be reduced or both sides have to be done. This question very clear that you may have to do both the sides and get the same answer as LHS and RHS. Cot A, LHS is equal to cot A minus cos A by cot A plus cos A, which is the same as cos A by sin A minus cos A divided by cos A by sin A plus cos A. LCM of the numerator, LCM of the denominator, which is cos A minus cos A sin A divided by sin A. Again, cos A sin A. It is cos A plus cos A sin A divided by sin A. Multiply by the reciprocal, which is cos A minus cos A sin A divided by sin A, multiply by sin A by cos A plus cos A sin A. It shows that sin A gets cancelled. Now you can take common factor from both the expressions. That means cos A into 1 minus sin A divided by cos A into 1 plus sin A, and further you cannot simplify, leave it. The same answer you should get with the right hand side also. RH is equal to cosec A minus 1 by cosec A plus 1, 1 by sin A minus 1 by 1 by sin A plus 1 by LCM, again sin A into sin A, which is the same as 1 minus sin A by sin A divided by 1 plus sin A divided by sin A. If you multiply by the reciprocal, into sin A by 1 plus sin A, 1 minus sin A by 1 plus sin A, which shows that LHS and RHS are equal. Therefore, left hand side is equal to right hand side. The last worked out example, prove that sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 is equal to 1 by sec theta minus tan theta. I think by seeing the question you can understand the familiarity from the exercise question. This is a very important 4-mark question. It will be asked as such. Now, when you see here sec theta and tan theta, it gives you an idea is sec is 1 by cos and tan is sin by cos. That means you divide all the terms by cos theta. First step is divide all the terms of LHS by cos theta, because we are going to start with the LHS only. Sin theta by cos theta minus cos theta by cos theta plus 1 divided by sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. That means all the terms are divided by cos theta, from which we are getting it as tan theta, then plus 1 by cos theta plus sec theta minus 1 by, I'm just shifting now itself because you already know the concept, tan theta minus sec theta plus 1. Now we will be changing this 1 as, how is identity? 1 plus tan square is equal to sec square, or 1 is equal to sec square theta minus tan square theta. So tan theta plus sec theta will be retained as such, minus that 1 can be written as sec square theta minus tan square theta divided by denominator no change. Now this will be factorized as a square minus b square. Numerator, let it be in a bracket. That means tan theta plus sec theta minus, factorize it as sec theta plus tan theta into sec theta minus tan theta divided by denominator, no change as it gets cancelled, plus 1. From here you can understand that tan theta plus sec theta and tan theta plus sec theta is a common factor, which means that tan theta plus sec theta will be a common factor. For this tan theta plus sec theta, you will retain it as a 1. This minus will be brought down, and with the bracket sec theta minus tan theta divided by the denominator will be tan theta minus sec theta plus 1. And now tan theta plus sec theta into 1 minus sec theta plus tan theta divided by 1 minus sec theta plus tan theta. It is the same topic. You get cancelled and you are getting the answer as tan theta plus sec theta. Read it as such. Now, here the right side is different. Just multiply and divide by the conjugate. So, RHS is equal to, here we start with LHS. RHS is equal to 1 by sec theta minus tan theta. Since done, our method, we have to get the answer tan theta plus sec theta, will multiply and divide with the conjugate, that is sec theta plus tan theta divided by sec theta plus tan theta. 1 into sec theta plus tan theta is sec theta plus tan theta, and the identity is 1 plus tan square theta is equal to sec square theta. Therefore, sec square theta minus tan square theta is 1. You can see here a plus b into a minus b, that is sec square theta minus tan square theta, or sec theta plus tan theta by 1, or therefore LHS is equal to RHS. It's a very important question. Thus, chapter 8 trigonometry is over. The textual questions are over. I hope you can study it very well. Continuously work out all the sums from the textbook thoroughly, and you will be able to do it, as the exam point of view they will ask mostly either the same questions from the textbook, or if at all from other books, it will be only the easy questions which will be asked for the exam.